It's really difficult to talk about best practices because there's no one size fits all. Everybody's got a different approach, and we really subscribe to a kind of teach how to fish approach. So I'm going to talk about that and kind of how we have in our software development try to take that into account, that we've tried to have as much flexibility and make our tools as relevant, even if you're not a primary user of them. So I'll talk a bit about how we recognize there's so many wonderful tools. At last count, 60 plus great tools that are open source tools in this microscopy analysis world. And they all have merit. And we recognize that we want to create more of an ecosystem. So I'm going to talk about what things we're trying to do to create a community and how this ImageJ driven community may be relevant even if you don't use ImageJ. And if you do use ImageJ, things we're trying to do to make ImageJ more relevant to you. And so I'll be talking about this idea of an ecosystem that we're trying to go beyond just one application, but have help and support. And as many of you know, I really believe in the concept that we want to empower bench biologists to do great work and to make the tools as easy to use and extensible as they can. So I'll talk about that. I think it's always good to know that who you're talking to and kind of bias. So my bias is I'm very excited by optical microscopy for trying to look at the microenvironment of wounds. And so I use this to look at cancer and diabetes and Alzheimer's examples of wounds. And the reason I have a slide here is to show that how the kind of imaging I do and many of you do can really drive informatics problems, right? And so in my case, I'm trying to look at different multi-parameters of the fluorescent signal. And increasingly, these have gotten more advanced over time. Things like dynamics and structure, of course, have been long established, but have gotten better with better perspectives like light sheet and faster and deeper with multiphoton. Of course, you've got chemistry and physics, which have always been mainstays of fluorescence, but now we're starting to realize there's chemistry and physics of the actual signal, things like fluorescence lifetime and second harmonic. And this would be the only science slide I have, but I wanted to point out that sometimes we get so excited by the microscopy, of course, that we forget about the informatics being really the biggest challenge. You know, that's really the frontier. You know, as someone who's been building optics for about 25 years now, I've seen the evolution of my lab that it used to be when we built a microscope, the challenges were often purely physical science and optics, but now a lot of the challenges really are the computational. They don't always get highlighted as much as they should. And many of the images we collect, you can't see with your naked eye. And so, and many of you in the room do the same thing. So I really think it's important that we highlight these things in red here: image acquisition, analysis, visualization, and image storage. And I'm delighted to see that CZI agrees and that so many of you are funded to work in these areas by CZI and other entities. So that's what we're going to talk about today. And in general, I'm very interested in this idea of an image informatics workflow where you try to understand the complete life cycle of your data set. And many of you in the room represent every one of these. And there's a real interesting effort to try to change the paradigm where the birth of your data set is when it's acquired and the death is when it's published, right? There's a lot of interest in going beyond that and having better data workflows. And you can see here, the idea is having these bi-directional arrows. And a lot of this work we've done with partners, notably the open microscopy environment has been very active in this area. And they're one of the, been very active in CZI as well with their bioformats efforts. And we've been involved in the early stages of that as well. A lot of efforts with Micromanager and quite involved in this meeting as well. And Nico Sturman is a new fellow working on this. And then of course, ImageJ and NIME and SOAR Profile are examples of analysis tools, but there are many, many others. And what we decided to do almost 2 years ago was Ann Carpenter and I, of SOAR Profiler fame, decided that we needed to align. And I'll talk more about this alignment and alliance, but we realized that we wanted to just have a place that we could discuss work agnostic of any given tool and to have all the different tools that we knew of be in one place. And to our delight, this thing called the forum has really taken off way more than I ever thought it would. And it belongs to the community. We just help support it, but it's not our tool. We believe it's the community's tool. And if there's any message from this meeting or my talk, I would love if you use this. I think it's a great place. We have over 60 software packages. And in the past, if you want to discuss image analysis, you'd go to confocal listserv, which is a wonderful place if you want to discuss confocal. But if you want to discuss image analysis, we needed a better home. And I really like how the community has taken ownership of this. And we'll talk more about how people can use this to teach themselves and how to fish and ask questions and explore. But if you remember anything, I would love to see you guys use this forum and actively engage and contribute, because it's only as good as how involved you are. That is the community has to participate for these kind of resources to work, because it's your collective expertise that is way more valuable than any one group, including mine. So we are fortunate that we've had the strong support of CZI, and we'll talk more about that as I progress with some examples. I'm also presenting from one of my programmers this afternoon, who's a CZI fellow who couldn't make it due to family issues. So I'll talk this afternoon more about his specific work, which is focused on interoperability and working with other software tools through CZI. But the NIH-P41 is an effort through NIH, through the Institute for General Medical Sciences, where they wanted to form a center with us where we could try to not only look for common missions between SolarProfiler and ImageJ and help fund the continued development of these two programs, and I'll describe more what we're trying to do with ImageJ, but also build community. And so Ann Carpenter and I were able to have this grant, serve the cell biology community, and we're trying to develop new software. But we also now have resources to really improve our dissemination tools and our training. So we're very, very open to discussing ways that we can help you, and the forum is one of them. The other announcement you've heard from my colleagues in BINA a day ago is that Chan Zuckerberg really has been instrumental, not only in funding, but also in guidance of really making BINA happen. And I'll talk a little at the end about the little summary that you already heard about a day ago, but essentially we have now resources, including 2 open positions that I'll describe again, that could create a community. So we think between COBA and CZI and BINA, and of course the forum, which kind of intertwine between all these entities, we now have the resources to help with your pipelines. And I'll talk more about that. And so COBA is, of course, about the development of Fiji and SolarProfiler, but you'll see many of our efforts are trying to help other software tools, not only in conferences and hackathons and in the forum, but as I'll talk about in a little bit, we're also trying to develop code that can be reused by others, even if you don't use ImageJ directly. So when you think about ImageJ, it's been around for a long, long time, right? I wrote a review with Wayne Raspin, the original author at NIH, and it's incredible to see its original roots as NIH Image in 1989 all the way to now. And actually recently, Nature picked NIH Image ImageJ as one of the top 10 impactful software or computational stories ever, which is pretty amazing if you consider all the great things that have happened in science and computation. To choose ImageJ and NIH Image is really a testament to how impactful it's been. I also think it's interesting enough a testament to what happens when you leave a smart guy alone in the basement of NIH, right? So Wayne Raspin never had a mandate to create this tool. He created it himself, and a lot of what we're doing is building on that. And I think the success of ImageJ has never been about great code. It's been about great users and great contribution to code. There are many, many software tools that develop great code. What's unique about ImageJ is that users contribute, and that will again be something I'll discuss in depth about the importance of contributions, and not only contributing help on the forum, but if you have great macros or scripts or plugins, sharing them. And that open source is beyond just passive use. It's active contribution, and that's something that's very important. So we have, of course, added to the full suite of what ImageJ can do, but perhaps the complexity. And so one thing I do want to explain as we go through it, that this ImageJ ecosystem contains a lot of elements now. There's Fiji, which is the preferred way, kind of the batteries included way of using ImageJ. There's the original ImageJ 1, which we rarely talk about because we also have ImageJ 2, and these days, it's been so long since we developed ImageJ 2, and so much is integrated into the new Fiji that when we say ImageJ, we usually refer to all this. But we did do a lot of work to make ImageJ 2 more relevant for you, particularly with modern data sets, and I'll talk a bit about that. And then we've also made ImageJ a library, and I'll talk about why these libraries are relevant in terms of sharing code, particularly talking a bit about SciJava, but a little bit about ImageLib. SIFI, I won't have much time to talk about, but this really is just a way of extending the great work on bioformats that started my group and now has really been championed by Jason Swedlow and OME, and is also funded by CZI in part. So there's a lot of great work done here. But for today's talk, we're really going to talk about the the different modules of ImageJ and why they're important for users to extend their work. So the mission of ImageJ really is about trying to develop the next generation ImageJ. But when we think about our mission, we really want to collaborate. So we really take quite seriously these elements where it's not enough just to develop a better program. We have to be driven by the users, and we have to think about sharing and reuse. And again, while there are groups, including mine, that put a lot of resources in ImageJ, none of us own it. This is really your tool. And what makes ImageJ great is not any one lab, but is all the end users. And it's, even though we are lucky to CZI and other partners to have professional developers, it is really the amateur bench scientist, or the amateur coder who's also a bench scientist, that has made ImageJ great. And we've tried to really keep that element and try to add things to make it easier for them to contribute. We are continuously trying to make ImageJ more useful and relevant, including to other software tools. We're delighted that, for example, now ImageJ Plugins can be used in other packages. We'll talk more about that. As you might imagine, the big elephant in the room, of course, is that ImageJ is Java-based, and we recognize the power of other languages, including Python. I'll talk a little at the end about how much we're trying to work on Python, and that really is the main focus of Curtis Rudin's work as a fellow that I'll talk about this afternoon, of really focusing on Python support in the ImageJ world. And then we really want to have a central online resource, which has been a major emphasis of COBA, but also our CZI work, of having a place where you can go not only for ImageJ work, but any image analysis help, like the forum and other resources, and having a clear vision of the future, which is keeping things working, but also adding new support for new modalities, such as Lightsheet. So ImageJ is an open source tool. It has been for some time. I figured for this audience, I didn't need to go over the benefits of open source in interest of time, but I think, as all you know, we very much respect and believe in commercial packages. I have many commercial software packages in my lab, including ones from major vendors you all know, and they have a place. But the advantage of open source, particularly open source supporting these commercial programs, is that there are just things that you can do in terms of transparency and sharing. And we really do think that open source is not anti-commercial. And so if you have questions with that, we can talk about that later. But we really are very interested in working with vendors and other commercial entities to support open source. So we think open source can very much be a tool of the commercial element and not a competing issue. And then beyond ImageJ being an end user application, which it has been for some time, as part of this ecosystem, we're really trying to create the shared network and shared framework and libraries so others can reuse it, particularly in scripting scenarios, or scenarios like Jupyter Notebook are the kinds of examples you may want to run your code in some shared or cloud version. And as an end user application, Fiji has really been the major tool of choice. So I don't, again, this talk is not a science talk, so I'm not going to talk about all the great things you can do with ImageJ. I think all of you either know about ImageJ, or many of you are absolutely advanced users of ImageJ. But of course, it's become very established for doing all sorts of things, including these 4 applications. And Fiji has become, a major mainstay. It's the original developer really loved pun on words. So it's at one point it was probably confusing to people why it's called Fiji, but I think Fiji's become so accepted now we would never change the name. And Fiji has a tremendous community of users, developers, including major developers like Florian Jug and Pavel Tomacek and others that have really made Fiji what it is in this community. And the neat thing about Fiji is that if you have been using it, we did something quite controversial at the time that, again, gets to Vlad's point about kind of building pipelines, supporting users, is that we didn't want to break anything. So the version that Fiji use now includes all the backwards support for ImageJ 1. And I remember the reviewers really were quite upset of the grant we submitted for that, because it took us almost 1.5 years to add that support and make it work well. And it was important to us because we didn't want to fork or break the community. And we wanted to make sure that if you use Fiji and you really like ImageJ 1, you still can. And so there was never an attempt to force anybody down from pipeline. And we wanted it so that all your old code would still work. And so we're delighted that at the very least of our efforts, even if you don't use all the ImageJ 2 functionality, at least your old code will still work and run well. And in some cases, take advantage of maybe improvements, even if you're using some of the legacy code. And when we say from now on, for the rest of the talk, when I say ImageJ, it refers to everything, not just one particular version. So I think I want to spend some time on, though, is really this concept of learn how to fish. When Vlad and I talked, we talked about, kind of what is the workflow, and it may surprise you, but you probably, definitely recognize that University of Wisconsin is a very large university, a tremendous student body, over 44,000 students, a lot of grad students and faculty. And people find out that we're on campus, and we often get asked for help. And we struggle with how to do appropriate analysis pipelines, and how do we train people, and how do we work with our user base that's at local, because we want to be good citizens, not only to the global and national community, but also be good neighbors to people locally. And what we decided to do, this may sound radical, but we do this at UW, and we even do it for people in my own lab, is we move as much as we can entirely to the online help. So there are collaborators that routinely email us for help, and we say, can you first ask in the forum? And even people in my own lab ask for help. And there have been certainly cases where people in my lab have asked for help on the forum, and they get questions answered by people in the lab that maybe are just a few desks away, right? And you may wonder, why we do that, but the power of it is that if we really drink our own Kool-Aid and really believe in the concept that we're all in this together, and that no one really has a question that someone else probably hasn't thought about or also wants to ask, and by sharing this together. So that's why our biggest part of the image analysis pipeline is that when we have a problem, we look to open source tools, we see if there's online examples, and then we ask. And then if we come up with a solution, the hope is that person would be comfortable in sharing that solution, ideally by giving back to the examples we have. And so one thing I ask all of you is that, many of your CZI grants have great plans for image analysis tools or pipelines or local training modules for your centers. Would love to see these tools shared openly. And I think that we can learn from each other. And one focus of BINA that we'll talk a little about at the end that Allison and Claire already touched on a day ago is trying to share these things. And if we can in BINA and Eurobioimaging and global bioimaging, get better at not only sharing the open source code, but sharing the approaches, right? And that's one thing we find that is documentation is always behind. And while we share plugins and code, that code is not as powerful, and it's going to be used not nearly as powerful if you don't share examples of what you do, right? And what makes ImageJ great isn't actually just the code that was developed, that is the infrastructure, it's all the plugins and macros. And you wouldn't want to use ImageJ if people never share those, right? So I guess sharing is the biggest thing you can help others. And it's sharing your problem, and it's also sharing your solution, which we often forget to do. And so this tool has been quite powerful for that. And I think the thing we're trying to work on more and more is making sure that when people find a solution, they share that as well. So that's not only sharing your problem, but also sharing how you got help. And delighted about all the tools that have joined. If you are part of a software tool and you're on this call, or you know someone is, or you use a software tool, you don't see it listed, we would love to see you guys join this. So the idea of the plugin concept is, it was really made ImageJ great. It was actually an original concept of Wayne's at the time. It was quite a novel idea, is being able to extend the functionality beyond what it can do. So this has been something that is really an important part of ImageJ, and you can see just how many plugins are available, over 1,000 plugins. Fiji really bundles them in a microscopy friendly form. So Fiji really is for microscopists, but a lot of other fields use ImageJ, and there's soil science and astronomy and all sorts of other fields that use this. And so they may package their plugins differently. One effort that I think has become really important is the idea of update sites. So any of you who run core facilities, you can actually update your plugins and manage them, but you can also run your own version of Fiji. So many people have made their own custom installs for their given place. And I think that's important. Scripting, again, is very powerful. And I think while plugins require some programming ability, scripting is a very, very friendly way of bench scientists that have no programming background being able to reproduce. And there's been a big effort to maintain the really easy ways of doing reproducible science. So doing scripting in the ImageJ macro language and making that very easy. But as you can see here, we're also trying to extend that in Python and other languages as well. And one of my favorite things is a pipeline tool. If you're on this call and you have no programming ability, I think one of the kind of great kind of unheralded tools is this ImageJ macro recorder. There have been many scientists who's never programmed before that have written really tremendously powerful macros and scripts by using this idea of kind of a little tape recorder you can see the link there, where you have this running. Whenever you do manually, it automatically creates a script. And so this is a way for a bench biologist with no programming background to be able to do automated analysis without actually asking someone else to write it for them. And I think this is really an important concept. It's also a great way to learn the syntax. So if you see, it's very human readable. So if you see the commands that come up from that recorder, you oftentimes can learn how to modify that, much in the same way you might read HTML and try to understand how a web page got formed. And so it's very readable. We've also really worked hard to make this a library. And so trying to go beyond just the application. And this has allowed us to build this side Java concept, which is you can think of it as a foundational layer for all things image processing in Java. And we've been able to team up with a number of partners, including Omero and Icy and Sort Profiler and Nime and so on. So it allows us to share our code and the ability to import data in with bioformats is a good example of some of the side Java work, but there's many other things, including how to represent n-dimensional data, for example. We have been working a lot on ops. So this is a library to add functionality for algorithms. So if you want to write more sophisticated tools, they have basic algorithmic functionality in ImageJ, kind of akin to MATLAB, but more open source and available. And this works now and is built in ImageLib 2. And this is this data container for n-dimensional data. And you can use it for different scripts. And we've added a lot of functionality, but you also will hear more in future things we're doing about that we're also trying to link to all the goodness in Python. So trying to combine the worlds where in this ops structure, you'd be able to use ops that we write, but also extend to other libraries that exist, including those wonderful ones in the Python world like NumPy and SciPy. We've also tried to make ImageJ something that is more relevant to users in different workflows that go beyond the old paradigm. It used to be the paradigm was everything on one user, one desktop, and also fairly small data of different data types. And a lot of work has gone into going beyond the 8-bit restriction of the old ImageJ to adding all these different elements on the right there and actually adding it so you can have more than 2 gigapixels, and a lot of work on making it run on the cloud, including headlessly. And so we, as part of this COBA Center, we're working on getting it to run on large national networks, including the Open Science Grid. And this is important to us so people can use ImageJ in that context. We also try to make the program very modular, so you can actually have layers for everything and different ways of going through it. And I think this is important for a developer and a user, for a developer in particular, because this is how you actually get into each component. But for a user, it also means that the program is more powerful for you, because it means that developers can reuse things for your use. And it also means if your user gets into scripting, you can use some of these things at the command line. So modularity is important to us. As I mentioned in the beginning, this is something that is probably the #1 focus for us right now, particularly with our CZI funding, is we have to make ImageJ more relevant in the languages that work. And in particular, you'll be hearing a lot in the next few months, including a forthcoming release of our PyImageJ effort, where there are a lot of reasons why ImageJ and Java are still very relevant, and sometimes Java is misunderstood as, as having issues of security or being grandfathered out. There are a lot of reasons why ImageJ and Java will stick around for some time to come, but to be relevant, we need Python support. Python is, or be most relevant. Python is just an incredible tool, as all of you know, language, and lots of goodness in that. So adding Python support is a real priority in our collaborations. We are only one piece of a community. There are many resources and websites for ImageJ, as you can see here. I want to highlight again the forum and all the various ImageJ related pages. We are trying to do more hackathons. Of course, a lot of these hackathons got stalled with COVID, but we will come back with these. And if any of you want to work with ImageJ developers or you want to have workshops, our group is happy to help organize these. We have strong collaborations with New Bias, which is a very prominent image analysis network in Europe, where we're delighted as part of the beta effort that many of the New Bias people are helping us with plans in the US to improve these kind of image analysis networks. And I'm happy to talk about that as well. And if you're just getting started in this world, I think starting at New Bias Resources, they have great workshops. Of course, the ones we'll plan in the future from Bina and COBA, and then of course the community forum. And Anna and I and Nico Sturman and many others, including I think several of us on this call, worked quite closely with iBiology to create a series of image analysis videos, and encourage people to always look at iBiology. It's just a tremendous resource, and we hope to create more of these kind of resources through BINA as well. Not only videos, but also tutorials. I think Drupal Notebook is a fantastic resource for creating tutorials, and so trying to do more of these kind of training materials for folks. And then just a real quick recap of what you heard 2 days ago is that we do have this new working group that I'm the liaison for, but Thomas Pango is lead of. And this is a very new working group. I'm delighted that we've already invited 5 people and they've all accepted from around the US, but we're looking for more. So if you're very interested in becoming part of this or knowing more about it, please contact me or Thomas. But this is for you, and this will be an effort to really organize image informatics in the US and Mexico and Canada as part of BINA. And Thomas Pango has strong ties to the new bias effort. So we're very lucky to have him involved. And so definitely ask us for help. Another advertisement, again, thanks to CZI for this, that we're delighted that we have these 2 open positions. I'm equally delighted we already have some great candidates, but I'm very interested in seeing any of your applications. If anybody's interested in this or want to know what this is. One unique element is the administrator position does need to be placed in Madison for lots of reasons, including synergy with the rest of our administrative team. But the program coordinator can be located anywhere in the US, even though they'll be payrolled by my Madison group. They can be anywhere physically in the US. So ask me if you have questions on that. And that will result in a lot more programs because we'll have more resources and people that are dedicated full-time to BINA instead of the more part-time effort we've had. This will be announced officially, but I thought I'd mention it here that we've always had this tradition of an ImageJ meeting happening every other year. And in recent years, we've been at ImageJ and Friends, and this has become more of an image informatics conference rather than just ImageJ. So while ImageJ is certainly a theme, any software tool that's open source can be part of this. And we've had prominent examples of great tools, including IC, many others as part of this. This was supposed to be this fall, but due to COVID, we've delayed it because in polling the community, it became clear that people wanted to have some online element and that the Zoom fatigue was high, so people wanted to have an option of being in person as well. So this will be a hybrid conference, and it's going to be in April of 2022. The date is pending, just a few other people getting back to us, and it'll be announced on the ImageJ webpage. But if you have questions, let me know. And this will be free to attend, and you could also attend remotely as well. We have learned, I think, that travel can be difficult even post-COVID, and so hybrid is a good thing. So I'd like to end there and thank all the various members of our community that have helped. I'm sure I left some people out, so thanks to everybody, including those that I don't specifically mention, and everybody in my lab group, and special thanks to the Chan Zuckerberg Initiative for funding us and funding all of you and bringing us all together. I think the value is beyond the funding. I think it's the intellectual sharing and the organization of us as community that's equally valuable.